We will now show that the temperature of the coffee after 10 minutes is given by this equation. That is, T of T equals 20 plus 75 e raised to the power of negative kT, where k is a constant equal to zero point zero 0.02. And for this, we are going to use this Newton's law of cooling formula, which states that the temperature of an object after 10 minutes is given by this equation. That is, T of T equals Ts plus T0 minus of Ts e raised to the power of negative kT, where Ts is the surrounding temperature, or we can say the temperature of the environment, and T0 is the initial temperature of the object, and K is a constant. So in our case, the temperature or the room temperature is given as 20 degrees C. This is basically the surrounding temperature. So we have the surrounding temperature equal to 20 degrees centigrade, and T naught, which is the temperature of the coffee. This is the initial temperature, that is T naught equals 95 degrees centigrade. So we plug this information into the equation. Therefore, T of T equals Ts, which is 20, plus T naught minus Ts, that is 95 minus 20 e raised to the power of negative kT. And when we simplify this, we get T of T, that is the temperature of the coffee after 10 minutes, is equal to 20 plus 95 minus 20 is 75 e raised to the power of negative kT. However, we still have to find the value of k. For that, we will use the given information. That is, after 30 minutes, it cools to 61 degrees centigrade. So that means when T equal to 30, the T of T equals 61 degrees centigrade. So we will utilize this given information to determine the value of k. I'm going to plug in T of T equal to 61 into this equation, and T equal to 30. So therefore this equation becomes 61 equal to 20 plus 75 e raised to the power of negative k. I replace T by 30. So this becomes negative k times of 30. Now we can subtract 20 from both sides, which gives 41 equals 75 e raised to the power of negative 30k. We divide both sides by 75. So this gives 41 over 75 equals e raised to the power of negative 30k. We then apply natural logarithm to both sides. So this becomes a natural logarithm of 41 over 75 equals a natural logarithm of e raised to the power of negative 30k. And when we apply the properties of logarithms, this negative 30k comes in front. So therefore, the next step, I can write down this equation as natural logarithm of 41 over 75 equals negative 30k times of natural logarithm of e. Remember that natural logarithm of e equal to 1. So therefore this becomes negative 30k times 1 is just negative 30k. Now to determine the value of k, we divide both sides by negative 30. So therefore I divide both sides by negative 30, and this means the value of k equals natural logarithm of 41 over 75 by negative 30. So when we plug this into the calculator and approximate to two decimal places, we get the value of k equals 0.02. So we have determined the value of k equals 0.02. Therefore, we are able to prove that the temperature of the coffee at time t is given by this equation. That is, T of T equals 20 plus 75 e raised to the power of negative kT, with k equals 0.02. Let's answer the question in part B. That is, we have to determine the average temperature of the coffee during the first half an hour. So for this, I'm going to use the average value of a function formula. That is, f average is given by 1 by b minus a integral of a to b f of x. That is, for a function f of x defined over the interval a comma b. This is the formula to find the average value of the function. So which means we can utilize this temperature function to determine the average temperature. So first I'm going to plug in k equal to 0.02 into this equation. So this becomes 20 plus 75 e raised to the power of negative 0.02 T. So this is the temperature function. The average temperature, let's say this is denoted by T average. This equals integral of, since we have to determine during the first hour, we can say that A equal to 0 and B equal to 30. So we write down this as 0 to 30. Then we have to put 1 by B minus A. We calculate B minus A equals 30 minus 0, which is equal to 30. So I put 1 by 30, integral of 0 to 30, and then the temperature function, that is T of T dt. Now let's replace T of T with the equation. So this becomes 1 over 30, integral within the limits 0 to 30, 20 plus 75 e raised to the power of negative 0.02 t dt. Now we can split this into two integral. That is, this will become 1 by 30. I put the square bracket and then integrate. Integration of 20 is 20 dt. So I can write down this as 20t plus integration of e raised to the power of negative zero point 0 t. This will become e raised to the power of negative zero point 0.02 t divided by this constant, that is negative zero point 0 t. So this will become negative zero point 0.02, and then we have to evaluate within the limits 0 to 30. So let's calculate this. So therefore this becomes 1 over 30. We then apply the upper limit, that is 30. When we apply the 30, we get 20 times of 30, and this is 75 divided by negative zero point 0.02. So we can do that, and when we do that, we get 3750 e raised to the power of negative of 0.02. We replace t by 30, so therefore this becomes 30. So this is what we get when we apply the upper limit 30. We then put minus. We now apply the lower limit, that is 0. So therefore this becomes 20 times of 0. Once again, this is negative 3750 e raised to the power of negative of 0.02 times of 0. We close the brackets. So we can simplify this. So therefore this becomes 1 over 30. 20 times 30 is 600, minus we simplify this, and we approximately get 2750, sorry, 2058.4. We then put this bracket minus, this is 0, and this negative of negative will become positive. So therefore I can in fact remove this bracket and put this as a positive of 3750. This is e raised to the power of negative 0 is in fact 1. So this basically becomes 3750 times of 1 is 3750. So we can simplify this, and we just have to add these two quantities and subtract uh, this quantity, and then finally we divide by this 30. So when you do that, we get the approximate average temperature. So we get 76.4 degrees centigrade. So this is the average temperature of the coffee during the first half an hour.